Hello students, welcome to the course Verilog Hardware Description Language. In the previous 4 videos, we have covered the topics of Unit 4. They are module definition, port declaration, connecting ports, and hierarchical name referencing. Okay, so in the today's class video, we will be doing some exercises. So how much you have understood. Okay, so to clarify, how to use the port declaration, okay, how to connect the ports by ordered list, by name, all these hierarchical name referencing. So just we'll see small exercises. Okay, the first one, what are the basic components of a module? Which components are mandatory? It is a question. Okay, so what are the components you have seen in a module definition? Okay, they are components, module name, right? So module keyword is there. So other than that, module name, port list, port declarations, then parameters in case they are optional, declarations of wires, registers, and other variables. Okay, then data flow statements. Okay, then instantiation of lower level modules, then always and initial blocks, tasks and functions, and finally end module statement. So in this, so what are the components mandatory they have asked? So any module of a Verilog should have a module keyword, then a module name. It may be design block or stimulus block, name should be there, and then you can have an end module. Okay, so this module should be end. So these three components are mandatory and remaining will be optional, right? So this we have seen. So we'll go for second question. So this is a simple one. Okay, also I have asked in assignments also. Next, does a module that does not interact with its environment have any IO ports? And second question in that, does it have a port list in the module definition? So what is your answer? And you should support with valid reasons, right? Does a module that does not interact with its environment have any IO ports? Yes, it can have, right? There are unconnected ports we have told, right? So that's why it does not interact with environment, still it can have ports. Okay, so that is true. Whereas, does it have a port list in the module definition? Okay, so in the module definition, so it will not have any list of ports. Like that it can be. Okay, so that is the solution. Clear? So just go through the 4 videos if you have not gone through. Okay, so now next we will have real exercises. Okay, if you have not gone through, just pause it here and go back and see and then come back. Okay, it is interesting to solve the exercises. So third one, a 4-bit, understand the question clearly, a 4-bit parallel shift register. Okay, so has IO pins as shown in the figure below. Okay, so it is a shift register of 4-bit. So the input, okay, so it is a serial in, serial out maybe. So it is having 4-bit inputs. Okay, and to run the, these are sequential circuits, so clock is required, synchronization, and then serially out. Okay, so register out of 4 bits. Okay, so there is a 4-bit parallel shift register they have told. Okay, parallel 4 bits will be out. So what you have to do, write the module definition for this module. The module name also they have given, use it as shift register. Okay, shift underscore reg is the name. In that include the list of ports. Okay, so this ports you need to list it, and then you have to do declaration also, which is input, which is output, using the keyword. Okay, very simple. You do not need to show the internals. Module internals not required. So how this is to verify? So you have understood list of ports and port declarations. Okay. Okay, so let us solve. So hope you have the answer. Pause it and do the answer and then verify the answer. Okay, so write module name, list of ports, then which are input, which are output, how many bits. Simple. Okay, so that's what shown here. Okay, module name was given shift underscore register. Then any order you can write. Output is written register out, register in, clock. Here no need to mention how many bits. Just your name you have to write. Then in declaration you have to do it clearly. So it is output. So output normally can be declared as net or wires. In case if you does not declare it as register, so it will be declared as by default wires. Since it is a shift register, it should hold a value, so it should be declared register. So in the single line only you can do, and it is 4-bit vector, so 3:0. Name of the variable is register out. Okay, so then inputs are written. Similarly, input you could not declare it as register. Port connection rules we have learned. Okay, so it is also vector 3:0, name register in. Then input is 1 bit. Okay, so which is clock. Okay, so then you can show like this. So there is no need to show the module internals, and finally end the module. Okay, so this is the answer for the question 3. Okay, hope it is clear. We'll go for next and the last question. Okay, only 4 questions I have to discuss, but fourth question I have 4 sub questions. Okay, so just understand the topic clearly and try to answer it now only, so that you can next page you can just verify your answers, so that your level of understanding will be clarified. Okay, declare a top level module stimulus. They have given top level module name, also they have given stimulus. In that, define register in 4 bit, clock 1 bit as register variables. Okay, and register out 4 bit as wire. Okay, like this you have to declare. Instantiate the module shift register and call it sr1. So you need to call, so this is like a stimulus module, so you need to call that design previously we have written, so that you have to call by name sr1. Okay, so then in that module, so what you have to do, connect the ports by ordered list. So when you are calling this shift register, you have to, first case you have to call by ordered list, second case you call by name, connecting ports by name. Both you have learned, so that you have to do simple. Then third stage, you have write the hierarchical names for variables register in, clock and register out. Okay, so which is inside this stimulus module, right? So these variables, so using dot operator you have to write the hierarchical names. Then similarly write the hierarchical name for the instance sr1. So you are writing the sr1 there. For that you have to write, and also you have to write the hierarchical name for its ports, clock and register in. So inside that you have the 2 inputs, right? So that also you need to write. Simple. So we'll do one by one. Okay, so read the question once again. Okay, if you have not understood, then start with first question. Okay, so module stimulus, module name is stimulus. They have given, they have told register in and clock as register variables. So register in is 4 bit 3:0 and register is clock. Then output is wire. So this is the case in the case of stimulus block, right? So because output should be a driver, right? So that's why it should be a net, it should not be a register. Okay, so register out. Okay, then ordered list shift register with an instance name sr1. That also they have given the name, you use this. Okay, that's they have told. Then ordered list means which order you have written the previous module. Okay, first you have written the register out in small letter, I am writing the same in capital, then register in and then clock. If you have used their clock second and then register in, use clock here second. So this should be followed. So any order you write, but follow this ordered list. Okay, so no issues. Similarly, second one, connecting the ports by name we will see. Okay, so module stimulus register, so this is same, no changes here, register in, clock, register out. Now here we are using the by name. Okay, so shift register, its name sr1. Now we are using any order you can write. See here, register out I have written first, dot I have used, and inside that register out. That means this module register out, okay, value will be passed to the register out of shift register. Okay, similarly register in dot clock. So there I have, so I have used here ordered list only, but you can change it, no issues. Okay, but writing name format is like this, dot, then the signal of your shift register. Okay, what name you have used there, and then what name used in this variable. Okay, that you have to write in the brackets. Okay, so end module. Hope you have understood this. So now hierarchical names writing. Okay, so in case if you are curious, you don't want to see the answers, first you want to write, plus please write it now. Okay, then verify the answers. Okay, is it correct or not, what you have understood. Okay, so I am going to show the answers now for the last 2 set of questions. It is about hierarchical names. Okay, hierarchical names for variables. Okay, with respect to that stimulus block. Okay, so it was having only 3 variables, so just stimulus dot register in, stimulus dot clock, stimulus dot register out. As it is name, how you have given, as it is it should be. And Verilog is case sensitive. Okay, if you write small here, it will be different meaning, so it will be going wrong. Okay, Then similarly hierarchical name for the instance, so you have used a sr1 instance here, so that will be written like this, stimulus dot sr1. Okay, and they have also told that to write the clock and register one, so sr1 inside that clock will come, so that's why stimulus dot sr1 dot clock, stimulus dot sr1 dot register in. Hope it is understood. So this is a small exercise on the topic uh, modules and ports. Okay, so now what we have done so far in this module 1 and module 2 is try to understand the overview of digital design, modules and ports. Okay, so now you have understood the components of module, how to declare the first part. Okay, port declarations. So now next what you are writing module internals. Okay, so that it depends on which style of programming you are writing. Okay, so you are writing gate level, data flow, behavioral, switch level, four are there. Okay, so switch level is not in syllabus, the remaining three we are learning in next subsequent. So unit 5 we are learning gate level, then one step further data flow, and then behavioral. Okay, so then additional tasks and functions. So the next two modules will be focusing completely on programming, so very interesting. So for that whatever concept I have discussed so far is very essential. Okay, so just complete it. So okay, thank you, we'll see in the next video.